होता है. So let's see, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? So n is 2. There are 2 ways to climb to the top. 1 step plus 1 step. Okay, so you have 2 ways. I can either climb 1 or 2 steps. So I have 1 plus 1, or I have 2. When n is equal to 3, 1 plus 1 plus 1, or 1 plus 2, or 2 plus 1. So those are 3 ways. So let's try the base case. If n is equal to 1, return 1. If it's 2, return actually 1, 2, or 3 is less than or equal to 3, return n. Otherwise, we can return climb stair. You go 1 step down and 2 steps down. This will provide the correct answer, but the issue is it's going to recalculate some of the recursions. So we need to save some values. Just thinking how we would do that. So if we have many steps, how about we do bottom up? So how about we start with 1 and 1 again, and then 2 and 2, 1. Hold on a minute. If I think I might have an easier way. I have 1s, I have 2s. So, okay, looking at this example, I think I got an idea. So I can pick any of these lines. I can pick this line, then this, or I can pick this line, this line, this line, and this line. So wait, so how many 2 steps are possible here? So 1, 2, 3, 4, 5, 6, n is 6. How many 2 steps? I'll just call it t. The number of 2 steps, 1, 2, 3, 4. It should be n minus 2, right? Yeah. Number of 1 steps there are n minus 1 total 1 steps I can make. Well, in this case, it's 4 and 5. Now let's think about this. I'm thinking of a bottom-up approach, if that's even possible. If I submit what I already have, then what do I get? Time limit exceeded, n is equal to 26. There should be a better way, right? Yeah, I need to save the values. That's the issue. It's recalculating the values. So we do plus 1, plus 2, but there are also 2 steps from behind. 1 step, 1 step, 1 step, or 2 steps. The third one, it's 1, 1, 1, 2, 1, or 1, 2. For the fourth one, wait, and this here is over here. Now for this one, it's 1, 1, 1, 1. It's like this, but 1 added to it, right? Take all this and add 1 to them. Now it's like 1, 1, 1, 1, 2, 1, 1, 1, 2, 1. But we also have a 2 we did not consider. So 2, 2, right? 2, 2. Can also have 1, 1, 2, right? But the thing is, we are just taking this and appending 2 at the end. And we are taking this and appending 1 at the end. And it gives us this. Similarly, for this one, we are taking the previous one, appending 1 at the end. And this one, appending 2 at the end. But that's not different from what we are doing here. Let me think. I think I have an idea. How about we take this, add 2 steps, so we get these 2, right? Yeah, how about this? For n is equal to 6, we have, if we take 1 steps, it would be like this, right? 1, 2, 3, 4, 5. So instead of doing this 1, 1, we can take it as 2. Or instead of doing this 1, 1, we can take it as 2. Instead of this 1, 1, we can take it as 2. Wait, hold on. Let's say I have a multi-set of 5 1s and 4 2s. And that doesn't make sense. Let me think about this. Actually, hold on. There is 1 step here. There are 2 ways over here. 3 ways over here. And for this one, we are taking these 2 and adding 2 steps to it to get these 2. We are taking 3 ways over here and adding 1 step at the end to get these 3. So 5 in total. So this 5 over here is 2 plus 3, right? So the next one would be 3 plus 5. So the 6th one, we are taking all of this and adding 1 step to it. 1, 1, 1, 1, 1, 2, 3, 4, 5. We are taking all of this and adding 2 steps to it, right? 2, 2, 2. So let's see. 1, 2, 3, 4, 5. 2 over here, 2 over here. 2, 1, 1, 1, 2, 1, 1, 2, 2, 1. And then 1, 1, 2, 1, right? 1, 1, 1, 2, 2, 1, 2, 1, 2, 2. Okay, so let's think this through. So we have int array 3, 1, 2, 3. I should not have deleted that. Wait, if less than or equal to 3, return. And then now we do a for loop. Let's do int I is equal to 1. Actually, we do a while loop. So if I is 3, wait, where are four steps over here? For 3 steps, we have this. For 4 steps, we have this. For 5, we have this, right? But what is n even? N is 2, 1 plus 1. So 1, 2. Okay, it's excluding the first dot. 1, 2, 3, 4. 1, 2, 3, 4, 5. Over here, n is 5, not 6. For 4 steps, this is the, wait. I need to separate this here. Then I have 1, 2, 3, 1, 2, 3, 1, 2, 5, 2, 3, 1, no, 5 and 3. So I have 8 over here. And for 6 steps, I have 8 plus 5, which would be 13. Right? Starting with 3, it's 3. And then 4, it's 2 plus 3, right? How would I do this? So I have an array 1, 2, 3. So right now it's 1, n is equal to 1, it's this, n is equal to 2, it's this, n is equal to 3, it's this. But if n is equal to 4, I think I will replace this. N is equal to 4. 4 modulus 3 is 1, right? Yeah. And then I will do 2 plus 3. 2 plus 3, which is 5. For n is equal to 5, I will replace this. And then I have 3 plus 5, which is 8. So I only need 3 values, right? So I is equal to 3, array I modulus 3. Let's do I is equal to 4. I plus 1 plus it with I plus 2. And then return the ith value. Of course, do I plus plus. stdio include we have 1, 2, 3, which is expected. But for 4, I is equal to 4. We are getting 1. We are getting 3. Some reason. Let me think. I is equal to 4. 4 modulus 3 is 1, right? 5 modulus 3 and then 6 modulus 3. I think I need 1 over here. So 4, 5, 6. If I is not equal to n, then added else break out of the loop. Let's just why true. So we have 5, which is 3 plus 2, 8, which is 5 plus 3, 13, which is 5 plus 8. I really hope this works. So my runtime beats 100% and my memory beats 13.7%. Is there a way I can improve the memory? Okay, how about this? Instead of int, I'll have char and I can do I plus plus over here. Let me check if that is less than equal to n. Would this be correct? So we are doing I plus plus or wait, should be plus plus I. Incremented by to 4 and then we check, right? Why does it take memory? That's what I don't understand. Let me see if this gives the same answer. 2, 3, 5, 8, 13. 2, 3, what? Hold on. If I do plus plus 4, can I do that? No, I don't think I can. Int, let's just do k is equal to 4. Six and 4. Four and 3. Yeah, it's correct, right? 4 is sending back to. Why is it sending back to? Now it's working. Yeah, it increments I in the last loop, that's why. I think I should be doing I minus 1. I need to know how to get my memory higher. Okay, I should not be, okay, I has to be int because it's going to cause issues. This also has to be int because if it goes more than the size of char, then it would store the wrong value. Yeah, beat 62%. I don't know how to shorten this further. Let me see. If I remove this, if let's say we get 1, so I will be added over here, so it will become 4, but then it will be subtracted here, right? If the input is 1, let's say this doesn't exist, then we will get 1 mod 3 over here. Okay, let's see if this is correct. I just need to check no, it is not. Maybe we check if n is less than equal to 3. If that is true, then we do this. If n is less than or equal to 3, the value becomes n. So it's 0. So it's a 1, 2, or 3 over here, right? Now let's see. 1, 2, 3, 5, 8. Okay, let's see if this works. How is it possible? How is this creating lesser space? Okay, instead of using an array, they're using 3 variables. But I don't understand why that would be shorter. Maybe it's because these arithmetic expressions. I think it's because of these arithmetic expressions. That's why. Okay, let's try this then. If n is less than or equal to 3, return n. So current, past, current, and past. Previous, current, previous, past. So past is minus 2 and is -1. Okay, let's try this then. So previous is 3, past is 2, e2 for int I, which is 3, I less than n, I plus plus. Current will be previous plus past, and then the value of past is updated, the value of previous is updated for the next one. 55. Okay, we are getting the same answer, but let's see if it takes up less memory. It still beats 62. Okay, what's happening? I don't understand. Why does this work but mine doesn't? Over here, there are 4 ints. In my code, there are 1, 2, 3, also 4 ints. If I equal to n, let's try a while loop. While true. And I initialize I to 4. There we go. It's 94%. Nice.